Hello, 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 hello. Am I audible? Am I audible? Hello, 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 hello. Am I audible? Am I audible? Thank you, Ritika beta. Thank you very much. Thank you. So, uh, good evening to all of you. Ashman, hello beta. Yeah. So, welcome to my YouTube channel. So, today we will be starting electrostatic from the very beginning, right? Thank you, Ritika beta. Thank you very much. Hello, 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 hello. Anushka beta, hello. Anushka, hello beta. Okay. Okay, so let's start now. So let's start. 1 second. तो जब तक हमारे पास एनर्जी है ना सेशन तब तक चलेगा. Done? Hello beta. Praveen, hello. So let's start now. From the very basics of electrostatic. That means today we will be having the first class. Okay, first class of electrostatic. If you will having any sort of doubts or anything like that, you can just comment on it, right? I will be watching your comment continuously, so I will be answering your issue that you will be having towards this particular chapter. Okay, so basically, as we have the discussion on it in my Telegram channel, that yeah, which chapter we need to start now. So I got maximum sort of response from electrostatic, so that's why we are starting the electrostatic. So today we will be starting which chapter, beta? Electrostatic. Electrostatic. Done. Hello beta. Hello. Abdul Kalam. Hello. Okay. Electrostatic. Clear. But you won't find any chapter in your NCRT with this particular name. So basically, now electrostatic, the name is what? Electric charge and field. Electric charge and field. And electric potential. And electric potential. But as per the NCRT, we will be having two names: electric charge and fields and electric potential. But I'm just teaching here as per your complete examination. That's why I'm just calling it a electrostatic. Electrostatic, right? So now basically electrostatic, it is made from the two different names. Electro, the first part is electro. Electro means charge. Electro means charge. And this static means at rest. Static means at rest. So this particular name gives us the hint that in the whole chapter we will be discussing about charge, but the condition here is the charge should be at rest only. Charge could be in motion or also, right? But here we are only discussing charge and the phenomena associated with the charge, but the charge should be at rest only. In the whole electrostatic chapter, we are discussing regarding charge, but charge should be at rest only. Then this is the meaning of whole electrostatic. Done, no? Simple. So electrostatic is that branch of physics which deals with the charge at rest only. Simple definition. So this today we will be discussing only charges and types of charges, properties of charges. Then day after tomorrow we will be having second sort of a lecture, right? So continuously I will be delivering all the lectures of electrostatic, then current electricity, then magnetism. Okay, like this. Okay. So basically, we know now what basically is rest. We know it from 11th standard kinematics. We know what is basically rest, right? But here we have a new term, that is discharge. Discharge. Okay. So what is discharge? What basically is discharge? Okay. Look better to understand the term charge now. So let us take the example of an atom. Let us take example of an atom. Okay. You know that atom, we considered atom as a spherical thing, and which is having a nucleus like this. Okay. So inside this nucleus, we will be having a neutron, and second is what? We will be having protons. And in this particular orbit, we are having what? Electrons. We know these basic things, right? We know these basic things. Okay. Now, as we know from the previous classes, neutron carries zero charge. Neutron carries zero charge. Neutron carries zero charge. And proton carries positive charge. It carries beta positive charge. In the same way, electron carries negative charge. Electron carries negative charge. We know these things now from our foundation classes. What the atom is basically, how many subatomic particles we will have inside an atom, right? Neutrons, protons, electrons. And we also know one thing now, that this atom is electrically neutral. Initially or naturally, this atom is electrically neutral. Electrically neutral. What is the meaning of this term, electrically neutral? Basically, electrically neutral means it doesn't carry any net charge. Okay, that means net charge is equals to zero. Net charge is equals to zero, which simply implies that number of positive charge is equals to number of negative charge. Number of positive charge is equals to number of negative charge. Suppose this atom carries two positive charge. It carries plus 2 charge. Okay. So if it is an electrically neutral, so plus 2 is equals to minus 2. So what is the net effect is? The net effect is 0. Net effect is 0. Okay. So atom is electrically neutral means number of protons is equals to number of electrons. Positive equals to negative. So net charge is 0. Net charge is 0. Suppose if somehow, hello beta, but if somehow now, if somehow we create a situation in which number of positive charge, if somehow number of positive charge not equals to number of negative charge, if somehow we will create a situation in which number of positive charge is not equals to number of negative charge, so this particular condition states that the atom is charged now. Now my atom is what? It is charged. Okay. So now definition here, now a shortcut definition for NEET the charge is charge means a condition of an atom in which number of protons not equals to number of electrons. Number of positive charge is not equals to number of negative charge. Okay, done. Now how we will achieve this particular sort of inequality between protons and electrons? How we can do it now? Look it up. If this is my atom, if this is my atom, and if we remove electron, what will happen now? We have number of protons. We will be having number of protons more than number of electron. Number of proton more than number of electron. In second condition, if we add electron, now what will happen now? Number of proton less than number of electron. So in first case, proton is dominating. So this one will give a what? A positively charged atom. A positively charged atom. And this condition will give you negatively charged atom. So by this whole thing, we come to know that how we can make an electrically neutral atom into a charged atom. Done? Done now? So by this particular examples now, we conclude that how we can make a body positively charged and how we can make a body negatively charged. So in a shortcut way, I will be creating three different situations. In first one, I will write electron equals to proton. Second one, electron more than proton. Third one, electron less than proton. So this condition means this body is neutral. This condition means we have a neutral body. This condition means we have a negatively charged body. What we have? A negatively charged body. And this one is what? We have a positively charged body. Positively charged body. Clear? Clear now, beta? Any confusion from this particular topic now? How we can create a positively body, how we can create a negatively body. Okay. Ayushman, beta, if you need a the kind of definition of all these things, no, I guess you are in my Telegram group. There I have shared a PDF of my notes. You can just copy those notes, okay? And if we are making the charges, now what they can do, now be in the class, you will find your answer na, in the class also, okay? Be in the class. And we know that now. But we know that. What we know that? Electron carries mass. We know that electron carries mass. The electron, this body carries mass. We know the mass is very, very, very small or low, but still it carries mass, no? Still it carries mass. Done? Now we are comparing these three. Now look, one, this is initial, we are comparing these one. So in this case, negative. How this body become negative charged? Because we have given some extra charge to it. Look, beta, we have given some extra charge to it. That's why this body becomes negatively charged. That means its mass will increase. Mass increases. Mass will increase. How? Because when you are giving some extra charge to any material, na, so you are just adding some mass to it. That means mass will increase. How the body will become now positive charges? When you are just taking a mass from it, when you are taking an electron from the particles, from the object, na, its mass will decrease. When you are removing electron, mass will increase. Sorry, when you are giving electron, mass will increase. When you are removing electron, mass will decrease. Mass decreases. Mass decreases. Done. Easy, no? Easy or very easy? Easy. Okay. This is basics of electrostatic. Now, I don't think that I can be just go to the depth of this topic. This is, I guess, good. No, beta. Very easy, no? Very easy now. If you are ejecting electron, it will become positive. If you are giving electron, it will become negative. Done. Okay, and what is charge? Charge is the state of a body in which number of electron not equals to number of protons. Simple definition. Simple definition. Look now. So that means we know now. We now know what basically charges are. Okay, how we can make a body positively charged and how we can make a body negatively charged. How mass will increase, how mass will decrease. We know it now. So we are now in the case now that we can give the answer to all these questions. Okay. 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 So basically, from the 10th physics, from your 10th physics, you know one equation that what is current? You know one equation now that is current. How you will define current? Sir, current means flow of charge per unit time. So what is current? Current is flow of charge per unit time. Done. From 10th physics. From 10th physics. Okay. We know these things, not? Sir, how what is current? Current means charge flow per unit time. Done now. So by this formula, can we write here that charge will be equals to, can we write here the charge will be equals to current into time? Can we write equals to charge will be equals to current into time? I guess we can write now this basic equation of charge. The charge equals to current into time. Okay, now if charge is q, current is I, so time will be t. This is my first equation. Due to this equation, I will be able to calculate my charge if current and time is given. But I can use this equation only and only when my current is constant. I can use this equation only and only when my current is constant. Done. If now my current is variable, how I can write the equation now? Sir, I can write current, this charge is equal to integration of current with respect to dt. This is what? This is the equation we can use when my current is not constant. When my current is not constant. So we came across two equations here, that when my current is constant, which equation I have to use now, and if my current is not constant, then which equation I need to use now. Done? Simple. Simple, huh? Yes, my voice is audible fully. Okay. Easy. Now, if I ask now here, is it charge a scalar quantity or a vector quantity? Is this charge a scalar quantity or a vector quantity? What will be your answer? Scalar or a vector? Huh? Yeah, integration is important. Integration is important. Now, throughout the physics, integration is very important. Integration and differentiation. If you don't know how to use integration and differentiation, you can just watch my lecture now on the basic mathematics. You will get to know how we can implement integration and differentiation in any numerical. Then now, okay, is this charge a scalar or a vector quantity? Huh? So charge is a scalar quantity. Charge is a scalar quantity. Charge is a scalar quantity. Great, beta. So charge is a scalar quantity. And you know now what scalar quantity means, right? Those quantities in which only magnitude is there and no direction is there. This scalar quantity. हाँ मेरे लेक्चर पढ़े हुए ना आप देख सकते हो कुछ महीने पहले मैंने वो लेक्चर बनाए थे you can just watch those lectures based on the basic mathematics. Now if we now talk about it is unit, if we now talk about the unit of charge, we know that we have two big system of units. One is MKS, also known as SI. One is CGS. Done. In MK or in SI, we have one famous unit of charge, that is Coulomb. That is Coulomb, represented by letter C. And by using the equation charge is equals to current into time, I can write it as a ampere into second. Ampere second also. Done. By using this equation, we can conclude that ampere second is also a fundamental or a SI unit of my charge. Huh? Now, if we talk about CGS, so in CGS we have two unit system also. We have two unit system. One is electrostatic unit. One is electrostatic unit. Okay, electrostatic unit. One is electromagnetic unit. One is electromagnetic unit. In a very shortcut way, electrostatic unit is equals to ESU. And electromagnet is equals to EMU. ESU and EMU. Now, here, what is ESU? It is a system of unit also for my charge in CGS. And in this particular system, we measure the charge in stat coulomb. We measure this charge in stat coulomb. And in electromagnetic unit, we measure the charge in what? Absolute coulomb. Absolute coulomb. Absolute coulomb. Done na beta? Any confusion up to this particular point? Any confusion up to this particular point? Huh? If you have any confusion, you can just let me know. Very easy, no? Okay. So no confusion now. Let's move ahead now. Look now. So 1 coulomb, if we talk about the conversion of units now, so 1 coulomb is equals to 3 into 10 to the power 9 stat coulomb. Stat coulomb. And also 1 coulomb is equals to 1 divided by 10 absolute coulomb. Absolute coulomb. Clear? 1 coulomb is 3 into 10 to power 9 stat coulomb, and 1 coulomb is equals to 1 by 10 absolute coulomb. Done. And 1 Faraday is equals to 96500 coulomb. So we have, by these things, we have one equation there, that absolute coulomb is more than stat coulomb. Okay, so this relation gives you the idea now which quantity is big, now absolute coulomb, then we have coulomb, then we have stat coulomb. Easy, no? Super easy, huh? Now if we talk about now dimensional formula of it, now if we talk about the dimensional formula, dimensional formula okay, so how we can write the dimensional formula of charge? How we can write the dimensional formula of charge? Either we can write Q or we can write AT. We can write AT. Sir, why AT? As we know that charge is equals to current into time. Current into time. So look from this equation here. Now look, current is A and time is T. That's why we write AT also. Easy. Now let us do one numerical. Now based on the equation that we have written over, now that the Q equals to IT and Q equals to integration of I dt. Now, so where we can use these equations? Let us suppose we have a question number first. That is, if my current is equals to 5 ampere. If my current is 5 ampere, find charge. So we have to find our charge Q in first 20 seconds. So find our charge in first 20 seconds. So from this particular equation, what is given to us? Now, beta, current is given to us. Okay. And time is given to us. And we have to find out charge Q. You can see now the current is constant here. You can see from it is a value now, it is constant 5 always. So which equation I can use here? Which equation now? I can use equals to, sir, charge equals to current into time. Simple. And current is 5, time is 20. So I guess I can write charge is equals to 5 to the 10, it is 100 coulomb. Charge is 100 coulomb. Mohammed Wahib, hello beta. So we have one international student also here, right? So current is what? Current is 100 coulomb. Easy? Easy or super easy, no? Easy or super easy? Huh? Easy, no? Yes. Look now. So in which conditions we have to use the second equation now, that current is equals to integration of I dt. So let us write one more numerical. Let us do one more numerical. And numerical is my current is equals to 3t plus 2. Find charge Q. Find charge Q in first, let us suppose 10 seconds. Now, as you can see from this particular equation, no, my current is a function of time. So this current is not constant. It is not constant, no? Sir, how you are sure that it is not constant? Look now, if I will place T1, so it will become 5. If I place T2, it will become how much? 8. That means the value of current is depending on the value of time. So my current is variable. If my current is variable, in this particular situation, I have to use the equation the charge, that is q, is equals to integration of current with respect to time dt, and I have the initial condition now, that is in first 10 seconds, that means from 0 to 10. It is 0, so here what we have 10. Okay, how we can do the integration? I will put the sign as it is, 0 and 10. In the place of current, I will write 3t plus 2, then dt. Okay, so here I will show you how we can do the integration. Look, I will, 3 is constant, so I will take 3 as it is. Integration of t would be t square by 2. T square by 2, then upper limit is 10, lower is 0, plus the integration of 2 will be 2t, and upper limit is 10, lower limit is 0. Okay, now look, 3, I will take 2 also outside, then what we have? We have 10 square minus 0 square, plus I will take 2 outside, then I will have 10 minus 0. Look, it is 3 by 2, it will be 100 plus 2 into 10. Done, no? The 2 ones are 2, 2 5s are 10, 2 zeros are 0. So we will be having 3 multiplied by 50, then it is 20. So you can write 150 plus 20. So my answer came out to be 170 Coulomb. My answer is how much? 170 Coulomb. Okay. So these are some conditions where we have to apply the previous equation and where we need to apply this equation. Okay. Based on the parameters which will be given to us in a numerical. Okay, we have to manipulate the equation as per the requirement of the question only. Current is constant, so we can use the previous one. Current is variable, so we can use this one. Look now. So now will be discussing properties of charge. Now we will be discussing about the properties of charge. Okay. No issue, no issue, no issue. Now what we will be discussing? We will be discussing regarding properties of charge now. Properties of charge. Properties of charge. Okay. The first property that we will be having about charge, these are additive in nature. These are additive in nature. So what is additive in nature means? Additive in nature means that you can simply add or subtract your charges just like the numbers. Okay. If somebody will ask you, but what is the addition of 2 and 2? If somebody will ask you, what is the addition of 2 and 2? So you can write 2 plus 2 is 4. If somebody will ask you what is the addition of 10 and 5, you can do 10 plus 5 is 15. If somebody will ask you what is 20 minus 10, so you can write 10. Okay. In the same manner, you can apply this concept here. Now, if you will be having 10 Coulomb plus 10 Coulomb and minus 5 Coulomb, and if somebody will tell you what is the net charge that you will be having, so you can write 10 Coulomb minus 5 Coulomb gives you 5 Coulomb. Done, no? Let's take an example. For example, this is my system, no? So this system contains plus 10 Coulomb minus, what happens with it? Minus 8 Coulomb plus 2 Coulomb. Okay, this closed system contains 10 Coulomb positive, 8 Coulomb negative, and also 2 Coulomb positive. So how we can find the net charge of it? What is net charge? No? So simply you can add those things. No? So you can write plus 10 Coulomb minus 8 Coulomb plus 2 Coulomb. And what will be the answer? Sir, 12 Coulomb minus 8 Coulomb. Okay. Simple now, 4 Coulomb. So 4 Coulomb will be my answer. Easy, no? So as you are just doing with the numbers, no, you can simply use those things here also. The additive nature one. Okay. Simple, no? Okay, second one. Second property. Second property is like charges repel. Second one is like charges repel. Like charges repel and unlike charges attract. Which means if you have positive and positive, they will repel. They will show which phenomena? Repulsion. If we have negative, negative, also what will happen now? Same repulsion, repel. But if we have positive, negative, what will happen with these two? Sir, they will attract. They will attract. If we have negative, positive, same sir, opposite polarity, they will attract. They will attract. Done. Easy, no? Super easy. Super easy, yeah? Okay, now, third property. Third property of charge is, sir, it is invariant. It is what? Invariant. What is invariant? That means speed dependency. Speed dependency. It is meaning now speed dependency. So you can write here, sir, charge is independent on speed. But you can write, sir, charge is independent on speed. Independent on speed. So you can write charge. Charge is proportional to speed. And the power of speed is 0. That means constant. Okay. So charge is what? It is independent on speed. So which simply indicates if this is my object which I charge plus 1 coulomb. Now if this object is accelerating, okay, if it is moving, so there won't be any effect on its charge. No effect of the speed. So it is the meaning of what? Charge dependency. No, beta. No. I will take the class for next, I guess, 20 minutes, then we can just end the class. If you want to finish this class in a one go, now you can just ask me now for the same. I can do it. There is no issue. Okay. But I need to just I want just you people need to enjoy the class. No, it is very enjoyable lectures. Okay. Chapter is very easy. Concepts are very new to you. You need to enjoy these things. And I am teaching you from the basics. No, beta. If you find any difficulty and if you find any sort of things that you are not understanding, you can just let me know here. Okay. Okay, now. So it is third property is charge dependence. Sorry, speed dependency. Charge doesn't depend on the speed. And what is the fourth property? So the fourth property is what beta? Charge conservation. What we have here? We have charge conservation. Charge conservation. What is charge conservation now? Charge can neither be created nor destroyed, but we can just move charge from one place to the another place. Okay, and this is valid for only this charge conservation is valid for isolated closed systems only. Isolated closed systems. Done now. It is valid for isolate closed system. So it simply gives you idea that in isolated system, total charge is conserved. Total charge is conserved. but positive and negative, but positive and negative charge may change. So what is the meaning of this statement? Now look at it. If I have a system like this now, and this system contains charge plus 20 coulomb. In second go now, so we can observe one more change to it now. So I can write plus 22 minus 2 coulomb, or I can write it as a plus 40 coulomb minus 20 coulomb. We can write it now. So look, what is the Q net here? What is the net charge here? Sir, it is 20 coulomb only. Here, what is the net charge? Sir, I can write net charge is equals to 22 minus 2 coulomb, which gives you 20 coulomb. Here, what is net coulomb? Net charge, I can write 40 coulomb minus 20 coulomb, which is 20 coulomb. Okay. So charge conservation is valid for isolated systems. But inside, the value of charge can be changed. Na? These can be changed. But overall, charge is conserved. Q net we have 20. In second figure we have 20. In third we have 20. But inside now the charge fluctuate takes place. First we have 22 minus 2, then we have 14 minus 20. But the overall charge is only 20. This is what? It is charge conservation. This is what beta? A charge conservation. Now let us do a fifth property. Let us do a fifth property. What is fifth property? It is quantization of charge. It is what? Quantization of charge. So quantization of charge stated that if there is a charge transfer takes place from one body to the another body, if charge transfer takes place from one body to the another body, it will take place in the integral multiple of electron only. It will get transfer in integral multiples of electron only. That means if this is my body first, body A, and if this is my body B. So let us suppose charge takes place from A to B. Flow of charge takes place from A to B. That means electron. A body ejects electron, B body receives electron. Okay, or I can write here now. Let us go Q. Q charge transfer takes place. Q. So quantization gives us the guarantee that the charge will be only the integral multiple of E only. That means the value of Q would be 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, and so on. Charge won't be in sort of fractions. It won't be 1.2, 3.7, 5.3. No. Whole electron will transfer from one body to the another body. Either one electron will transfer from A to B, or 2 or 3 and 4 and so on. Okay. It is not possible that half electron will transfer from A to B. Done, no? So if this is the property, so what is the minimum value of charge that can transfer from one body to different? So that is n only. If look here, n is integer, so the value of n would be 1, 2, 3, and so on. So what is the minimum value of n? Sir, it is 1. Right? So if I can write n1, so it will be how much? Q is equals to plus minus E. So the minimum charge that can transfer from one body to the different body, it is what? Electron. And this charge is known as what? Quanta. This is what? Quanta. So quanta is the amount of charge which is equals to the charge of an electron. So if somebody will ask me, what is quanta basically? No? So quanta is the amount of charge which is equals to the charge of an electron only. It is quanta. The minimum possible charge transfer from one body to the another body. Done? Done? Easy, no? And you have heard about the milk in oil drop experiment. Okay, the milk in oil drop experiment, which proved this quantization concept. Milk in oil drop experiment. Okay. So this was the experiment which gives us the quantization. Milk in oil drop experiment. Done. Now, but we have some exceptions also. We have some exceptions. We have some exceptions. Done now. We have some exceptions. So these exceptions, these are given by the Gale-Man. These are given by the Gale-Man. And Gale-Man gives us the concept of quarks. Gale-Man gives us the concept of what? Quarks. And Gale-Man gives us the concept of quarks like that we have two types of quarks. We have up quark, we have down quark. And the charge on up quark is plus 2e by 3. Charge on this down quark is minus e by 3. Okay, minus e by 3. Look now, and the Gale-Man told us that proton is made from these quarks. Look now, so he suggested that the proton is made from 2 up quark plus 1 down quark. 1 down. So look, 2 charge of up is equals to 2e by 3 plus 1 charge of down is minus e by 3. So you can conclude it 4e by 3 minus e by 3. Look, basis same, so you can write 4e minus e by 3. It is equal to how much? 3e by 3. Cancel out, so we got plus e. So we know that charge of proton is how much? Plus e only, right? Yeah, we confirm it. The second point is about what? Neutrons. So neutron is made from 1 up quark with 2 down quarks. So look, 1 up quark. So I can write 1 into 2e by 3 plus 2 down quark. Down is how much? Minus e by 3. So you can see here now it is 2e by 3 minus 2e by 3. Cancel each other. So the charge of neutron is 0. So by this one, we can prove that the neutron and protons are made from the quarks. Neutron and proton, these are made from the quarks. Then how these quarks doesn't get transformed from one body to different body? It is because that these quarks doesn't exist independently. Okay, before getting transfer from one body to different one, before that these quarks get transferred or transformed from quark to the proton or neutron. Okay, there is no independence existence of these quarks. So you can write here independent existence. Independent existence. Independent existence of quarks. Not possible. Not possible. So if the independence of these quarks is not possible, therefore quantization is still valid. Therefore quantization is still valid. Then therefore quantization of what? Quantization of charge or is still valid. So we have completed how many topics? I guess 5. Now sixth one, no? Sixth one. Sixth one. Sixth one. Sixth one. Sixth one is if speed is 0. If speed is 0, it suggests that the charge should be at rest. Charge at rest. If my charge is at rest, that means only electric field is present. So charge will produce only electric field. Charge will only produce electric field. If my charge particle is at rest, so it only produces electric field around it. It will create only electric field around it. Second property, if the speed is not equal to 0, that means speed is present, but the speed is constant. If the body is in motion, but the speed should be constant. So with this parameter, electric field as well as magnetic field will be present. As well as magnetic field will be present, but constant. So if your charged particle is in motion, but if the speed of the body is constant, so electric field will be associated with your particle, but constant electric field and also constant magnetic field will be present around your particle. Third point, if my velocity or speed is not equal to 0, that means body is in motion and the speed is also variable. And speed is variable. So what you can write? You can write it will radiate energy. It will radiate energy. It will radiate energy. Simply is electromagnetic waves. Okay. Walaikum assalam. I mean, electromagnetic waves, right? If your particle is in motion, but non-uniform motion, the accelerated motion, and this accelerated motion, your particle will radiate energy. So you can call it as an electromagnetic wave. So from this particular property, you can conclude that in electromagnetic wave, we will be having a particle in an accelerated mode. With an accelerated mode. Done? Now property number 7. Property number 7, we have here charge cannot exist without mass. Charge cannot exist without mass. Without mass. Charge cannot exist without mass. Example, if my mass is not equal to 0 and if my charge is not equal to 0, so the example would be proton. Example is proton. If my mass is not equal to 0 but charge equals to 0, what will be the example? So example is neutron. Example is neutron. Neutron is neutral. But what if my mass is 0 and charge is either not 0 or equal to 0? This one is not possible. Not possible. Done? So if mass is not there, na, so there won't be any sort of charge present. Then it is not possible. It is not possible. Either you can write this or you can write this. It's not possible. In both the cases, it is not possible. Then now we have one most important property. Most important property. Property number 8. It was the most important. Is what? Most important. Most important. Done? So the most important property is when we are giving the charge to any material. Material could be conducting or it could be non-conducting. If we have a conducting material, so the whole charge will be on the surface only. But if we have a non-conducting material, the charge will be throughout the volume. Throughout the volume. So what we can write here? So we can write here like in conductors. In conductors. Charge is distributed. Charge is distributed at outer surface only. At outer surface only. To minimize repulsion or potential energy. Okay. While as in non-conductors, if we have the non-conductors, in non-conductors, charge is distributed inside volume. Okay. So look now. Look better. So I will make here a table. So here I have a conductor side. Then in this side we have non-conductors. Look now. First case is what? Solid. If you have solid conductor, right? It is solid. Look, solid. Solid means mass is throughout it, no? Look, just like we have a disc, no? It is solid. So mass is throughout the body here, no? Mass is present, no? This line is represent mass is present. And if we are giving charge, so in conductor, charge will be on only outer surface. Charge will be only on the outer surface. Because if we have the maximum sort of distance, so maximum distance means minimum potential energy. But in case of non-conductors, it will be throughout the volume. Okay, it will be throughout the volume like this. So first case, my first case. Second case is if we have what? Solid with cavity. If we have solid with cavity. Okay, it is like this, no? Solid with cavity. Solid with cavity. Look, this one. So the material is only present between these two rings, like this. Look. Then, in case of conductors, charge will be only on the surface. Charge will be only on the surface to minimize what? Repulsion. But in non-conductors, charge will be throughout the volume. Charge will be throughout the volume. Okay. Now third one. Third one is what? Third one is C part. We have hollow. So no mass present, just like a ring. No? So look, in case of conductors, same. Charge will be the outer surface. Here also, because the material is not now present inside, no? So charge will be like this. So from this particular property, now we can conclude, look beta, this one, and this one. No? The charge distribution of this one, I can write 1, 2, 3, 4. So charge distribution of, look, charge distribution of 1, 2, 3, 4, same. If charge distribution of 1, 2, 3, 4 same, so they will have same property. They will show what? A same property in any electric field. Okay, they will have a what? Same electrical behavior. What will they have? Same electrical behavior. They will have same electric behavior. Done? So charge distribution is the key parameter which will guarantee how the material will behave in an electrical field. So from this particular example or particular property of charge, we can conclude that the conductor with solid or conductor solid with cavity, conductor hollow and non-conductor hollow, they will be having a same charge distribution. That's why we can call they will have a same electrical behavior. Same electrical behavior. Okay. If you have done the Gauss's law, in Gauss's law, there you will write, beta, the electrical field of hollow, conducting and non-conducting is same. Electrical, you can write there, electrical field of hollow conducting sphere and hollow non-conducting sphere is same. What is the reason behind it? Reason is that charge distribution of these two objects same. Done? Done, no? Any difficulty up to this particular point? Any difficulty, beta? Any difficulty? Okay. Now let's talk about, no, I guess we need to stop now, no? Okay. So we'll stop here. We will stop here. So in next class, we will be discussing about methods of charging, densities and Coulomb's law, okay? We'll stop here. If you have any sort of doubts regarding this class, you can just reach out to me in my Telegram group, no? You can just write Shakoor sir physics, or you can just go to the description part. You will find my Telegram group ID. Okay, beta? And thank you. Good night. Bye.